Okay, for 53, it sure does look like the prior problem, but unfortunately the test for divergence is not going to be helpful in this one over here, because the limit as n goes to infinity is going to be 0 for that. So what I do is over here, I look for a comparison to it. And I always say comparisons are tough because you're looking for something that compares to it. And I'm going to write this down for you. I'm going to compare this to, again, I get suspicions about it, but the suspicions don't always bore out, and I have to do something else. So I'm going to compare this with this over here, n equals 1 to infinity. I'm going to say, maybe 1 over n squared. And what do I know about this guy over here? It's convergent. Again, this could be a dead end. If it is, I'll just erase and try something else. I'll try 1 over n if I have to. So let's write this down. I'm going to use, I guess, the limit comparison test. I see it over here. That's a good choice. I'll put this over here. Limit as n goes towards infinity. And this is going to be 1 minus cosine 1 over n. And what goes on bottom would be 1 over n squared. All right. Let's take a look at that. So as n goes to infinity, the top goes to 0, the bottom goes towards 0. That's an interesting thing now, isn't it? So I'm going to look at the continuous case. I'm going to look at the limit as x goes to infinity. And this is going to be 1 minus cosine 1 over x. Trying to get a feel for what happens. And this is 1 over x squared. Let's write this down. Limit x goes to infinity. You're going to use L'Hopital's rule because the top goes towards 0 and the bottom goes towards 0. So what do you get there? You're going to get sine, let's see, 1 over x, right? And then the derivative of that would be minus 1 over x squared. What do you get in the bottom? We take that guy's derivative. It's going to be minus 2 over x cubed. Well, I got to clean that up. So x goes to infinity. I got to multiply. Well, I'll cancel the minus sign out. Multiply the bottom by x cubed and the top by x cubed. So what do you get there? Let's write this down. You're going to get the sine of 1 over x times x, and on the bottom you're just going to get the number 2. Now let's start to look a little more familiar to me. And this is going to be limit x goes to infinity. And I'm going to pull a half out. You get sine 1 over x, and on bottom you just get 1 over x. Well, lo and behold, I guess we've been doing this so often that we know that limit's going to be 1 now, so the limit's going to be 1/2. So let's go back up here. What do I know about this over here? It's 1/2. Again, after all that work, you may forget why you've done that. This is convergent. Limits comparison test. We found a finite number over here. This is also convergent. And we're done. Thank you.